What is IBM WebSphere MQ and what it can do? MQ stands for messaging and queuing. Messaging is the mechanism to define data as a message to exchange over the network. Queuing is the mechanism to hold data in a MQ server until processed by the remote service. This messaging and queuing framework defined by IBM WebSphere MQ. MQ built on Java. It is platform independent. It supports 80+ platforms. MQ is available to Windows. It is available to Unix, mainframes, AS400, like this. It supports 80+ platforms. It is an IBM middleware message transport product. It enables communication between two distributed applications over the network. Look at here, madam. WebSphere MQ, known as an integration engine. It integrates distributed applications irrespective of the programming language, platform and protocol, and it enables reliable communication. To integrate distributed applications over the network, WebSphere MQ provides an MQ API. It is MQ API. Through that MQ API, MQ server integrates all the services over the network. It enables reliable communication. Look at here. This is my Windows host and this is my Linux host. On this Windows host, an application is hosted on name Business Service. On Linux host, an application hosted on name Business Operation. These applications implemented in different programming languages. Now we wish to integrate these two distributed services to enable communication. So in between these two distributed applications, we configure an integration engine. It is IBM MQ server. This IBM MQ provides an API. It is MQ API. Programmers are going to implement MQ API interface. With this interface, application can connect the MQ server and it can put message in object queue. Queue is an object in MQ series. Queue is a file and data structure. It is container in MQ server to hold data. My business service defines its data as message. That message consists two parts. They are MQMD header and payload. Payload known as message body. In message body, as message body, application can define text data, binary data, XML data, non-XML data. Any type of data application can define in message body. This is how business service or an application defines its data as message, and it puts that message in object queue to exchange with destination and application. Here put is nothing but write. If destination and application available on online, it connects MQ server. It gets message from queue. Get is nothing but read. When an application retrieves message from queue, the message no more. MQ server supports once and only once delivery and guaranteed delivery. It is just like passbook. As you know, in passbook we can see transactions like credit and debit. Whereas in MQ server you can see operations as put and get. An application deposits the data in MQ server as messages. Other end application or one more application will get the data from the MQ server. When an application draws the data from the MQ server, the data no more. Just it is store and forward mechanism with assured delivery. If you compare IBM MQ server with DB engine, easy to understand. In our DB engine, we define tables to hold data permanently as records. Whereas in MQ server, we define queues to hold data in the form of messages temporarily. Are you clear, Shamya? See here, yes, I described IBM WebSphere MQ once again. Listen me. It is an IBM middleware message transport product. It enables reliable communication between distributed applications by integrating them over the network. It is known as an integration engine. It integrates distributed applications irrespective of the programming language, platform and protocol by providing an interface, MQ API. It is known as store and forward mechanism. Just it holds data and it forwards the data. It is just like passbook. On MQ server, major operations are put and get, write and read. An application writes data, an application reads data. When an application writes data, the data gets stored into object queue. When an application reads data, the data no more. Okay. Now I will define some predefined objects here. In MQ series, see, IBM WebSphere MQ here supports one-to-one communication, one-to-many communication, many-to-many communication, many-to-one communication, any type of communication it supports. And also it is able to support synchronous communication and asynchronous communication. Synchronous means both applications can available at the same time on MQ server to access the data, or they can run at different times. Okay. WebSphere MQ built on Java. Everything we define as an object in MQ server. In MQ, predefined objects are 7. They are queue manager, queue, journal, listener, process, nameplate, and service. These 7 are MQ predefined objects. To define names to MQ objects, MQ series allow char set is A to Z capital, A to Z small, 0 to 9 digits, 0 to 9 digits. Allowed special characters are dot, slash, mod, underscore. This is the only character set allowed by IBM WebSphere MQ to define names to MQ objects. There is a limitation about length. MQ series object name can have less than or equal to 48 characters except the channel name. Channel name can have less than or equal to 20 characters. Only channel name. To administrate these 7 MQ objects, MQ providing predefined commands. MQ predefined commands broadly divided into 3 types. They are control commands, MQSC commands, and PCF commands. As a WMQ system admin, we work with control commands and MQSC commands. We don't work with PCF commands. Control commands are around 20 to 25. MQSC commands are just 14. Control commands we execute at OS level. MQSC commands we execute at MQ server level. They are normal English words, I will show them. No problem. See, as you know, hardware on top of that operating system. On this hardware unit, I installed Windows operating system. Then this platform has become Windows platform. On Windows platform, we install Windows MQ. Once if we install MQ on Windows, it runs as a service. On top of that service, we host MQ objects. Look at here. Hardware, operating system. Here it is Windows. On this Windows host, I install Windows MQ. Then it runs as a service. By default, its status is running. By default, the status is running. On top of this, we host MQ predefined objects. In these 7 MQ objects, Queue Manager is an initial object. Queue Manager is first and foremost object in MQ series. Unless we create Queue Manager, we cannot define rest of the MQ objects. Queue Manager itself, MQ server and MQ engine. Queue Manager is a subsystem. It controls and holds all the MQ predefined objects. Queue Manager providing queuing services to the application. It is the single point of contact to all the distributed MQ applications to perform either put or get an MQ predefined queue. Look at here. Initially, I create Queue Manager object. Once Queue Manager object is created, with that control, we can define object queue, channel, listener, process, name list, and service. This is channel, this is listener, process, name list, and service. If you don't define Queue Manager object, you cannot define the rest of the MQ objects. Queue Manager controls and holds MQ objects. It is owner of the MQ objects. It is owner of the MQ objects. See here, if an application wants to put messages in queue, first it has to connect queue manager, then only it can access the queue. After that, it can perform put operation or get operation. This is put. If an application wants to get, first it has to connect the queue manager, then only it can access the queue. Then it can perform get operation. So here, what is queue manager? It is an initial object. It is first and foremost object in MQ series. Unless we create queue manager, we cannot define rest of the MQ objects. Queue manager is owner of MQ predefined objects. It is subsystem. It controls and holds MQ objects. It provides queuing services to the applications. It is the single point of contact to all the distributed MQ applications to perform either put or get on MQ predefined queues. Itself MQ server, itself MQ engine. Okay. See how already here I have shown you MQ API, right? Programmers implements MQ API in the program, then the program can define data as a message. It connects queue manager and it can put messages in queue. In the same way, destination application can connect MQ server and it can read the message. How the C programmer will implement this MQ API? How Java programmer will implement this MQ API? What type of coding they define, I will show you now. Just see here. We no need to bother about MQ API implementation. Developers will take care about it. We are responsible to administrate these 7 objects. Okay. Good. Look at here. Sample C program that asynchronously puts messages to a message queue. WebSphere MQ providing MQ API to C programming language as header file. Programmer includes header file in his program. MQ API header file includes in his program. He starts implementing the API. See, very first call, very first operation is connect to queue manager. For that, the API call is MQ call. In our C perspective, we say it as function. In our Java perspective, we say it as method. In our MQ perspective, we say it as call. MQ API call. Here MQ API call is MQ call or MQ call function. With this function, application connects queue manager. After connecting the queue manager, it has to open the queue to perform either put or get operation on object queue. So to open the queue object, application executes MQ open function on queue object. After that, the application defines the message. It puts the message in queue. So the call or function is MQ put. Connect, open, perform put operation, then close the queue, MQ close, disconnect from MQ server, MQ disk. Where I will mention clearly, see, connect, open, perform put, then close the queue, disconnect from MQ server. Here, connect MQ form, connect, open, get messages, close the queue, disconnect from MQ server. This is how MQ application perform operations on MQ server. Now if you come to Java, you can see here the program import packages. MQ provides MQ API as a jar file to C programming language. Programmer keeps the jar file in his class path and he imports MQ API packages. He implements the program. See, very first, what application has to do? Create a connection to the queue manager. To create connection to the queue manager, he defined an object on class MQ queue manager. Okay. After making the connection on queue manager, application has to open the queue. So to open the queue, he calls access.queue method. Through that method, he accesses the queue. He makes the program to define a message, and the program has to put the message in queue, right? So it executes queue.put. Program wants to get the message from queue. It executes queue.get. After performing either put or get, application has to close the queue. It executes queue.close. And then if it wants to disconnect from MQ server, queue manager draws disconnect. This is how programmers will implement MQ API. Then programs can put messages. Programs can get messages from MQ server. Yes, Shamyan, any conclusion?
It's quite good, like new things going on here. So I think I need some time to catch up.
Okay. See, programmers are going to define the programs. Okay, how they define the programs I have shown you. So that is MQ API implementation. About API, I have shown you sample programs. How they implement programs, all the things. Okay. Java type programming programs I have shown you. How they implement MQ API. How programs connect queue manager. What the method or function they call. So how they open the queue. How they can put message. How they can close the queue and how they can disconnect from it. I have shown you. MQ commands are consistent between the platforms. See, this is my Windows MQ. Already on this Windows host I installed MQ. Let me show you MQSC commands here. Here cursor is blinking but no command prompt, right? Here you can see the prompt but here no prompt. This is queue manager control area, madam. Now we are in test PMG or queue manager control area. This is name of the queue manager. I only created queue manager on name test PMG. At this console you cannot execute something. Then you can execute only MQSC command. Here I try to execute XYZ. It is not a command. It is not valid to execute at this console. The valid commands are as listed below. Okay. This command is only valid. If you want to quit queue manager control area, you can quit. That means if you want to define the objects or if you want to administrate MQ objects, you have to get into the queue manager. If you want to quit queue manager control area, you can quit. N number of times you can get into the queue manager. If you don't want to work at the console, you can quit queue manager control area. Okay, like this.
Okay.
Here commands are consistent between platforms. Now I will show you on Linux. Connect the Linux host. On Linux host also I install MQ. Here I log in as root. Yeah. It says MQ user. Some queue managers are running. Anyhow, let me get into one queue manager. MQSC followed by queue manager name. Now try to execute something XYZ or 1, 2, 3, 4. See, valid MQSC commands are as listed below. Okay. Irrespective of the platform, the commands are consistent. Administrative consoles also consistent. There is no change. As a WMQ system admin, most of the times or all the time you work with these commands. We have other commands also. They are control commands. Control commands we use it to administrate services. Services like trigger monitor, channel initiator, command server. This type of services we have. To administrate all those services, we use control commands. Okay. Yes, any queries?
No.
Yes, we are going to install MQ on Windows in our following session. I will share the overview documents to go through, as well as I share link to download MQ for Linux, MQ for Windows. Please download and be ready for the tomorrow session. You can initiate the installation. Okay. Just what is what? Just I have given overview. How many are MQ predefined objects? What are the predefined commands? Okay. Just outline if you see in MQ series, it contains 7 objects. It's like providing 40 predefined commands. Major operations are put and get. Data comes as message that gets stored into the object queue. Whenever remote service get the data no more. 7 predefined objects, 40 predefined commands, major operations put and get, data comes as message, it gets stored into object queue. Whenever remote service get the data no more. Okay.
Okay.
Just this is the discussion what is what. I share material go through. Okay.
Okay.
If you have any queries, let me know.
Yeah.
There are no queries, right?
Yeah, nothing.
Okay.